All right, guys, so now we're in part two, which has to do with cones. Okay, so part one had to do with pyramids, and the second part has to do with cones. Now, the idea is the formula hasn't changed any. The issue is the fact that we're only dealing with circles now, or a circular base. Okay, so that means when I first draw the shape of the base, it's going to be a circle. But the difference in the formula is the fact that we don't do the perimeter of a circle. The perimeter of the circle is called the circumference. So it's pi r. Okay? Now, the reason, now I'm actually going to write it out for you, but you'll understand why it's just pi r times slant height. Okay? The original circumference formula
Good afternoon, faculty and
is
staff. Let's
2
support Beth McGovern and
pi
Relate
r.
for Life and the students and the committee and wear purple tomorrow.
And then the second thing is it's 1/2 the circumference. Okay, now in your pyramids, we did 1/2 perimeter times slant height. Well, the reason it switches from this formula to this is because when you multiply the radius by 2 and then multiply by 1/2, these two things will always cancel out. Thus, you're always going to have pi r times slant height. That's why it changes, okay? Because these two things are opposites of each other. So instead of looking at it and going, oh, well, the perimeter is the same as circumference. So it's 1/2 the perimeter times slant height. So it's 1/2 the circumference times slant height. And the reason we can get rid of the 2 and the 1/2 is because they will cancel each other's out every single time. So now that formula is just pi r times slant height plus, and then the area of the base, which is pi r squared. Okay? And the reason, again, the formula changes is because the base is a circle, and it's always going to be the area of the circle. Now, that doesn't happen with pyramids because the shape of the base changes in pyramids. It's not always a triangle or a square. It could be a hexagon. It could be a circle, and that makes it a cone. Okay? But slant height is still the same. It's still the distance down the side of the shape. And you might have to do right triangle work to find slant height. Okay, so I'm drawing a circle, and I'm doing the first sample problem. Okay, so everybody can follow along. And just give me a second. I want to make sure that I get the right problem. Okay, then we move to here, and we're on page 'll double check. I gotta get to the right page. I'm sorry, guys. I apologize. It's 11. Three. All right. So I'm actually doing the sample problem that's there, the example problem, and the shape is the base, and I draw the radius, and they do give me the radius this time. It's 15. Okay. So now I go ahead and plug that into the formula. So I have pi 15. Then the slant height is down the side. It's the number I haven't used. The slant height would be 25 plus pi 15 squared. And I literally type it in my calculator. And hopefully you understand that this is the lateral area and the whole thing is the surface area, right? Because they always give us the surface area formula, but we should know that the first part of the surface area formula is lateral area, okay? And it's not times 2 area of the base, it's just one base because you only have one base. Exactly. Now let's look at the sample problem number 2. Okay, problem number 4 actually. This was example problem number 3. We'll look at example problem number 4. Now, the difference between 3 and 4 is that 3, they give me the slant height. 4, they do not. They give me the height of the figure, which is down the middle of the shape. So what do? I start by drawing this out first. And then, of course, I always draw the radius. And the radius in this problem is going to be 40. Okay. Now, they gave me a diameter of 80, but I know that I just want to write the radius. And then I write the formula. Surface area equals pi r slant height plus pi r squared. And I have the radius. But the slant height is down the side. They didn't give me the slant height. They gave me the height of the figure. So the right angle mark is here, and it's 45. They gave me the height of the figure. Well, I need the slant height. Well, then the number down on the one side of the triangle, because I got to do right triangle work to find the slant height, is going to be 40, right? Because it's the radius. And then I do a squared plus b squared equals c squared, and I square root it, and that's what I'm trying to find there. So, what do I tell people? I now have this formula, right? We know that it's 45 squared plus 40 squared. I take this and plug it in for my slant height. So I write the formula like this. Pi 40 square root 45 squared plus 40 squared plus pi 40 squared. Okay. When we're multiplying things, we always put it in parentheses so that it stays together. And literally, the slant height is this answer. Now, if you want, you can do all the math work you want and get a number underneath here and then put that there. But remember, if you don't put it in your calculator, you're going to have rounding mistakes. So when you check the book answers, compared to you're going to be off by a little bit. So the idea is understanding how they're more specific by keeping it in that radical form. That's why you have the calculator. Okay, it does really cool things like that, so you don't have to. All right, and do the got it problem, and then I'll have the got it answers up when you first come in, and we will go over the got it answers, and then you'll start on the lesson check. All right. Okay, thank you very much for listening to today's lesson. Finding the surface area of cone.